Hello, hello. Are we live? Cool. Welcome back to the Advent of Syntran. This is 2024, day 17. I think if we get another problem that's as hard as yesterday, I'm only going to do part 1. I'm not going to grind at it for 3 hours. I don't want to spend that much time streaming every night. So let's download the input. Let me edit my template. Let's look at the, have to CD. That's not a lot of input. But that's scary because day 11 wasn't one of the input, and that was one of the hardest problems yet. With the Plutonian pebbles, where you had stones that doubled. I thought that was hard. Alright, we got operands, registers, operators, literals. Oh my god. We basically have int code. For example, there's the test input. It was sus that these were both zeros, but that's real. Okay, so I should be able to run my template and echo the test input. There it is. No, what are we doing? We've got registers, operators, literals. It's basically int code again, isn't it? 3-bit computer. 0 through 7. Excuse me. Okay, 0 through 7. That's indeed true. The registers can be much more than 3 bits. Yes, if only I'd read that whole paragraph. Any integer. Is that true? Any 64-bit integer or any integer with unlimited bits? I think it's not really any register. At least your input won't be that, even if theoretically. Was that a bash script? What, my New Day downloader? It is a bash script. I've got ANSI colors. They're not functions, they're just constants. It has to have arguments. There's no Claude, there's no AI here. It only downloads the input. It doesn't do anything cool with the puzzle text. Yeah, and then it copies a template, which just reads the input. Curls, that's all there is to it. Yeah, I had some trouble on day 1 because I couldn't remember how to get my cookies. Last year I was doing this on a different computer, and I think I already talked to you about that. Okay, I have to read the rest of the puzzle. Opcodes. Right, so you have an opcode and an operand, and then another opcode and another operand, I guess. Instruction pointer starts at 0 and then it increments, right? Except for jumps. We have jumps. This is like all of int code in one day, though. Opcode, then operand, opcode 2, if I can select right, and then operand. Okay. so we have literals. Combo operand. Oh, two types of operands. These are not opcodes. Hey, Vision for All. How's it going? Okay, literals A through C. And then these are things from the registers. And operand 7 will never occur. Division. This is really long puzzle text. Oh, you only did the first part. I'll see. Did you ever do the int code problems? I forget which year those were from. So 14 stars, maybe it was 2019. Yeah. In 2019, they had a series of problems called int code, where it was very similar. You had opcodes, there were like addition operations, and your program was just a list of numbers, sort of similar. Oh, hey, yeah, no problem, plus mid. So this feels similar to the 2019 problems. And there wasn't just one int code problem. I think all of the ones that I did this year were int code problems because I've heard people talk about these. They're like some people's favorite advent of code puzzles. Not all 25 days were int code, but 1, 2, 3, 4, 5, 6, 7 different days were based on int code. So those were kind of fun. Okay, we have division. Okay. What are these ADV, BXL, BST? I don't know. Okay, bitwise XOR, I get that. But ADV, division. Okay, DV for division. What is the A? Oh, because of the A register. Okay. Oh, so they're like the first letter of these things, which doesn't actually appear in the program. It just appears in the puzzle text. It basically denotes the register. That makes sense. Bitwise XOR. Glad I have bitwise operators in syntran now. Like a month ago, I didn't. BST modulo 8. So what is ST? Close call. Oh yeah, thanks. I don't know if I might have figured that out after you commented it. Jump if non-zero. Okay. Bitwise XOR. What's the difference between BXL? Bitwise XOR. Okay, registers B and C. Then we have a print and another division. Well, I've got to be careful about that. And another division. Okay. Part 1 doesn't sound too bad. Does the program grow? Is this really the entire length of the program? Like, there's nothing that like appends data to my program. Because I think in int code, that's the way it worked. Like they might give you a short program, but then the program would kind of like generate itself by creating more instructions that got appended to the end of the program. Output doesn't do that. It's literally just printing. It's not adding data to the program. Okay. This might output multiple things. With commas. Are we not submitting an integer today? We have commas in the puzzle solution today. That's different. I like it. Why should it just be an integer? It's a text field. You can put anything in here. All right. Okay, so I'm basically going to have to reread this thing again while I start to write the code for it. So we have registers, A, B, and C. You can also parse the data. Don't think we need a loop to read today. It's just 5 lines, including a blank line. Okay. So how do I want to do this? I can just do, I have a read function which will ignore any non-numeric data. Do I have negatives? Because my function doesn't work with negative numbers. Input. Okay, no negatives. That simplifies my life. So register A, string. So this will just ignore any text that's not a number or not a numeric digit 0 through 9, and then put that into a vector. Yeah, it returns a vector. So do I have, okay, I think that should work. B and C, let's just print those. Does that work? That did not work because I have to read another string. Then we have to skip the new line, or blank line. Ugh. What now? One more. Okay. They are both zeros, so that should be correct. And then we have program. Is it called the program? Yeah. And then instead of reading one number, I actually want to read multiple numbers. So it's not a blank line now. Let's group the reads along with unpacking from those reads. I'm already doing that. Okay. See? That's why you group things in a logical way, because that would have not been good. Okay. So then program I32s. This will read multiple integers into a vector. These parsing functions, by the way, are not built into syntran. These are in my utility library. Leg, let. Okay, there we go. Is that right? Looks right. Now we evaluate. Fortunately, there's not really anything to tokenize or parse here. Well, I guess you could say we did the parsing, but like all you have are integers. It's a lot like int code from Advent of Code 5 years ago. You don't have to parse text. You don't have to like match parentheses or brackets. It's not like a real programming language. It's like they're already giving you assembly or bytecode. So there's nothing to lex, there's nothing to parse. You just have the bytecode immediately. And now we just have to evaluate it, which is like the whole problem. Okay, so we have registers. We're going to have an instruction pointer. It starts at 0, and then increases by 2, except for jump instructions. And then we go until we get past the end. And then, could it be before the beginning? We'll jump. Will we ever get a negative number from jump? I don't know, maybe. So let's be careful. While 0, it's just a scalar. And I pointer is less than size program 0. Okay, so that's the halting condition, I guess you would call it. And it increases by 2 on each iteration. Plus equals 2, and then to do, skip this if jnz, I think that's the instruction. Okay, now we have op instructions. We have instructions. So this is kind of like an enum. I don't have enums, so I'm just going to make them integers. But I want to give them names at least. They're opcodes. So ADV is 0. I'm going to capitalize these because they're basically constants. I don't have constants or immutability in my language, but by convention, I can at least capitalize them. So ADV, BXL, BST. There are 8 of these, right? Or maybe like 7 is reserved or something. Like for the combo operands, I know they said. I missed one. 5, 6, 7. Okay. ADV, BST, no, BXL. Maybe I can do this. That kind of works. BXL, BST, JNZ, BXC, out, BDV, CDV, and I think that's everything. Okay. So we have to differentiate between literals and registers. So we have the combo operand and then the operand value. So those are 2 different things. So the instruction is going to be whatever's at I pointer, and then the combo operand is going to be I pointer plus 1. So let combo operand equals These are in the wrong order. It's program I pointer +1. And then we have the instruction. That's program I pointer for symmetry +0. And then we have to get the value of the operand, which will depend on if it's a literal or a register. So 4, 5, 6, 7, or a literal. We have the operand value. I'm just going to initialize it to -1, and it shouldn't matter what I initialize it to. For then it's register A. I think they go in order. 4, 5, 6, and then 7 is reserved. So I want to check for that because it shouldn't happen in a valid program, but I can at least print an error message and be like, hey, something went wrong. You read the literal. After the literal, you get the combo. Yes, so this gets the literal. And then if it's not one of these cases, I guess we can do it like that. A, B, C, and then this is an error. I think that should work. Okay, now we have to do these operations. Let me reread this to make sure I did that right. Wait. Oh. Each instruction specifies the type of its operand. So it might just be a literal. Yeah, so I have to know which instruction I'm on. So which ones use combos? ADV, BST, out. Only 3 of them. So I can nest this. If ADV, BST, or out. ADV, any instruction equals ADV, BST, or out. And only then do we apply the combo operand logic. ADV, BST, and out. Okay. And then all of the other ones are literals, BXL, J, and Z. And some of these, yeah, BDV and CDV only work with the B register or the C register. So some of these like don't. Oh, no, hold on. These are like ADV. They just don't repeat that text. So BDV and CDV. Okay. Need to close a parenthesis there. All right. Default to literal operand. Okay, now we do the operations. Numerator is the A register. So if instruction equals ADV, just want to copy those. ADV, BXL, BST, JNZ, BXC, ELT, BDV, CDV. CDV. Do these out of order because I think it makes sense to group the divisions together. BXL, BST, BXC, ELT, BDV, and, oh, no, I already did BDV. Hold on, I missed one. One J. Where's my... Okay, I'm worried that I missed one now. After BST. Okay, so ADV, BXL, BST, JNZ, BXC, ELT, BDV, and CDV. Okay, I think that's all of them. And these are all else's. They're mutually exclusive, so it actually doesn't matter. But let's have a guard against it. And then I want to skip this for J and Z. So at J and Z, I will just continue. All right. This is the third time I've said this, but now I have to do the operations. Numerator is the A register. And what does it do with the result? The result is written to the A register. So reg A equals reg A over numerator is the A register. Denominator is 2 to the power of the operand. I don't think I need parentheses there. But I'll use them just in case I forget the order of operations. Pretty sure those are optional. I might not need brackets for most of these. I'll need it for J and Z because it has a continue. Or braces. If it's one line, the braces are optional. So let me reread that. Division. Numerator is the value in the A register. And the denominator is 2 to the power of the operand value. The result is truncated. That's just how integer division works. And then written to the A register. Okay. And then BDV and CDV are similar, except it stores the result. The numerator is the same, but it stores the result somewhere else. So the only difference is the left-hand side. The numerator is the same. Okay. And does CDV work the same as BDV? Like, imagine if they threw a twist in here where this was different. C register, the numerator is still from the A register. Okay, now we have everything except division. So BXL is bitwise OR with a literal operand. And then it's BXL, right? So register B, bitwise XOR the operand value. Okay, it's the operand modulo 8. Okay, so if A is not 0, we want to nest this continue, because if it is 0, then we want to still do this thing. That checks register A, and then I have to jump to the right thing. Register A is not 0, jumps to the literal. This is 0 indexed, right? I hope the instructions are 0 indexed. Okay, then only 2 more. BXC, bitwise OR, register B and C, and stores it in B. For legacy reasons. Okay. B and C store in B. B, it's bitwise XOR, and register C. Okay, and then out prints. I think I want to actually concatenate this to a string. And I'm going to have an extra comma at the end, and I'll just ignore that. Maybe I'll do something about that later. So let's have an output string. It's going to start out as an empty string, and then we're going to concatenate onto it. So out will concatenate onto the output string, and it has to cast the, what is it outputting? Is it a register? Combo operand. String operand, and then a comma. I think that's it. Except I'm not writing a sum here. We're actually writing the output string. And what should I return? I guess I have to return a string too. And then I have to change the signature of this. So this fucks up my whole program because my template program assumes that everything works with integers, not strings. Okay. And then this is just always going to return 0, whatever. All right. Will that parse? I probably have syntax errors. No syntax errors. 364? That's a big number. That's way too big. Is that... Yeah, something is wrong. The registers can store large numbers, right? So I'm not supposed to be like taking these mod 8 or anything. See, I ended modulo 8. Okay. So output does that mod 8. So I might not be far off. 463. Okay, there we go. Is that right? 463. And of course I have an extra comma at the end. I'm just going to not paste that into my answer. 463 563 5210. Okay. That doesn't seem so bad. Let's see if it works with the real input. And remember not to use the final comma. What? Okay, so what did I submit? I got rid of the trailing comma, didn't I? What does that mean? What's the debugger? Is this whole thing the debugger? Now I have to debug the debugger. I mean, the test input might not cover all of these, so I might just have a mistake in one of them. At least I never hit this. Plus equals 2. And then if I jump, I want to know what I'm jumping to. That's a lot of jumping. Well, it's not that much. Let me go back to the test input. Zero, 5, 3. I think they never have instruction 2. We had 0. We had 1. No, we did not have 1. So I might have a problem with BXL. Bitwise XOR. So BXL, bitwise XOR. Do I have to like explicitly make this 3-bit? Operand val. Should be else. Does that make a difference? I don't think that makes a difference. Is this the test input? Yeah, that's still the test input. So did that change anything? I think not. Three zero three zero 12536. That did not change anything. Zero 1 2 3 4 5 6 7. Bitwise XOR is commutative, right? I could do register B XOR operand val, and that's the same as operand val XOR register B. Because I kind of forget how like XOR equals works. But it's commutative, so it shouldn't matter. Okay, so which other cases have I covered? Let's go back to the test input. Okay, so we didn't have 1. We don't have 2. So let me double check BST. That seems simple enough. Don't have 2s. We do have 3s. We don't have 4s. BXC. Register B, register C, and then it stores it in register B. Am I initializing the registers correctly? Okay, so it has a big number for A and then still zeros for B and C. That's the test input. Okay, I think I'm initializing those correctly. Is this like 63 million? Do I need 64-bit integers? Because the registers could be big. But like, will anything make that bigger? We divide, we do modulo equals, and we do XORs. I don't think that can get any bigger, right? Okay, no 4s. So I think I just double checked that. Register B and C and stores it in B. Okay. Definitely doing else. And 6. 6 is BDV. What if I just like didn't paste my answer correctly? I've got to at least try it again. Because like it feels like there's not a lot to mess up in part 1. Let me just not even copy the trailing comma this time. Okay, there's no trailing comma there. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. No trailing commas, no spaces in the middle. Pretty sure this is what I already submitted. But I've got to at least double check that. Yep, still not right. Okay, maybe don't use compound assignment. Let's try that. Did I get this logic right? 4, 5, and 6 is register A, B, and C. 4 is A, 5 is B, 6 is C. And then which ones use the combos? combo ADV and then also BDV and CDV. So ADV, BDV, CDV, and then BST and out. BST and out. And anything else uses a literal. So BXL uses a literal. And is this if logic correct? So we start out with just like assuming it's a literal. So we get the program I pointer plus 1. That's the combo operator. And then we assign that to the operand val. So if we're not any of these instructions, then it's just going to use a literal. Did I accidentally use a double equals anywhere? Because that did bite me a few days ago. Okay, so BXL, it's not one of these, so that's a literal. And then what else? Uses a literal. J and Z uses a literal. So that's not in this list. Modulo 8. Is there anything else that's modulo? The BST instruction, whose like whole point is modulo. Those are the only two modulos. There really doesn't seem like there's a lot to mess up here. So what am I doing wrong? Okay, let's try getting rid of the compound operators. So register B equals register B XOR operand. It should be the same thing. Register B equals register B modulo 8. And register B equals register B XOR register C. I'm pretty sure this one is working. I'm pretty sure all of the compound operators work. These are covered by unit tests. String is a variadic function, so it can take any number of arguments and concatenate them. Did we have any jumps in the test input? Yeah, so we jumped to 0 several times. And it only ever jumps to 0. So that's kind of interesting. It never jumps to some other instruction. Wonder if it ever jumps to an odd number. Because then it sort of like swaps the meaning of opcodes and operands. Does that happen with the real input? Jump 0. Is it a bug that it's... Well, I'm getting the right answer for the test input. Okay, I think I've looked at all these. There are only 8 of them. So it only ever jumps to 0. That's pretty weird. Operand val. I guess that's just the way it works. But I'm still getting the wrong answer, right? Why did I put that in this directory? That's still what I submitted. What am I missing here? I'm close to going on to the... Let me read through these examples because I really ignored these. 2.6. You gotta do it more step by step for me. I guess I have to test these. Okay. So C is 9, and the program is 2.6. Test input 2. Test input, let me get the format at least. Okay, so C is 9. C is 9, and the program is 2.6. And then let me set this up. So I'm going to have another file, test input 2. No. The fuck happened there? Oh, extra comma. Okay, this outputs nothing. That doesn't seem right. A, B. Oh, it actually outputs nothing. So I need to print my registers here. Just to debug this. Sets register B. That didn't seem to work. Register C contains 9. Program 2.6. Why? What the fuck is that? So 2 was one of the operands that I was looking at, right? Is that B? No, it's BST. Register B. What? Hold on. BST. So the instruction is 2. How the fuck does this work? Opcode 2. Writes it to the B register. Oh my god. Oh my god. So that was wrong. Wow. This is a day where you just have to read the puzzle very carefully. Okay, now we set register B to 1. Is that my only mistake? I'm gonna cross my fingers and hope so, and just try the input again. I should do the other examples to see if there are issues there. Okay, ends with a 6, no comma. Ends with a 6, no comma. There we go. That took longer than it should have. I don't want to make anybody feel bad. Like, there are probably people, I don't know if they're watching this. Most likely nobody watches this, so it doesn't matter. But there are probably people who take way longer than an hour for a puzzle like today. So my intention is not to make you feel bad. But, I mean, my problem was that I didn't read the puzzle closely enough. Like, I actually double-checked BST because I noticed that the test input, the first test input, like this thing, it never does instruction BST. So I did double-check this, and I don't know if I triple-checked it, but I at least double-checked it. And I missed this. I was just doing B modulo equals itself by 8, but I was ignoring the combo operand. Okay, so what's part 2? Yeah, the root of my issue is that I just didn't read carefully enough. It's a quine. It's a quine in int code. Or we're supposed to find the quine in int code. Can I just brute force this? Vision for all, if you're there, did you just brute force this and did that not work? Like, by brute force, I mean iterating, start at 0, and they want you to find the lowest value, right? So the way I would do this is I would set register A to 0, run the program, see if it outputs itself, then set A to 1, rerun it, set it to 2, and just keep going until you find the program that outputs itself. So is that like too slow? Does that not work? Because if that doesn't do it, I don't have any other ideas. Yeah, if you have to optimize evaluation of this weird int code language, I have no idea how to do that. Anyway, I guess I'll try it. So I think I want to get rid of this trailing comma. First. True. Is that gonna work? No. No, I need to check last. So do a number and then a comma. Also, I think I can clean up a lot of this stuff. I mean, I can just trim the string at the end, but honestly, that's so easy. I'm just going to trim the string at the end. I don't know why not. Like, you have to copy the string one more time, but who cares? Okay, so I should be able to do... BST was my issue. So I should be able to do compound assignment there. Not here, because you're doing more than one number. It's not just compound assignment. It's operand val modulo 8, not register B modulo 8. If it was register B modulo 8, then you could just do compound assignment. But it's 3 different numbers, so you can't do that. This one should work. And then I have to make sure I still get part 1 at least. And then I'm going to trim the string at the end. So out string equals out string 0 through len nut. This isn't Fortran. I need a square bracket there. -1. Okay, can I still get part 1? I don't need all of that debugging. 506, 506. Is that what I submitted? 167430, 167430. Okay, that's still correct. There's a little more printing in here that I can get rid of. I want to keep the error messages. Okay. And that prints just the answer. All right, now let's try to brute force it because that's the only idea I have. I'll take part 1 and copy this. I was hoping for an easy day today because I streamed for 3 hours yesterday and that was a lot, so I don't want to do that again. If brute forcing doesn't work, I think I'm just going to give up. Maybe I'll look at Reddit later and see what other people did and try to port those solutions to Syntran, but I'm not going to struggle on this for 3 hours on stream. I'm just going to give up. Okay, so part 2, we're going to iterate and we're going to change A. So we're going to read the input. We're going to initialize everything. We're going to do all those. And then while true. Yep. Then I want to indent this. And we're going to iterate over register A. I think. And I want a string version of the program so that I can compare by string. Program str equals str. I think it's register A, right? That's what we're iterating over. Register A is corrupted. What if it's a negative number? What if you have to iterate downwards? Wouldn't that be a big fuck you to all the Advent of Code participators? I should be able to at least do the test input up to 2024. So and then we're going to check if the output is the input. So if alt string equals program string, then sum, this one actually returns an integer. Yeah, I don't know what to do about that. Sum equals register A. Oh, no, we want the initial register A. So I need to back that up. Or I can just set it up here. Set earlier. And then we just break. I'm still going to make it return a string. $182. That, yeah, I forgot to increment it. Sum plus 1. Because your program changes register A, so I can't just add 1 to register A at the end. I have to add 1 to whatever I backed up at the top of the loop. Oh, We also have to reset registers B and C. And the program never gets modified, does it? No, we never modify the program, but I do have to reset registers B and C. And if I do that, I might as well like make this readable. So let me change the way that I'm incrementing register A not, A, B and C, B, C, B, C, and then now, well, this one is kind of a special case. So we're setting it to that and then incrementing it inside the loop. So reset these, reg B not. Yeah, so I could see that if anyone tried to brute force this, you might like miss details like this. So that could be a gotcha. Well, it's supposed to be 2024. That did not work. So let's just hard code a break. Why did it get shorter? Am I running? I might not be running the test. Yeah, I'm not running the test input. That'll do it. That doesn't seem like that worked either. What is the input? That file doesn't exist? What are you talking about? There we go. Okay, what happened? Am I resetting? Resetting this to an empty string. Resetting the instruction pointer. These are all constants. The program should never be modified. So why doesn't that work? Isn't it weird that they're all the same length? Not at first, though. Here's an idea. If this needs to be optimized, you could check if your output is ever longer than your input, and then you can break. Oh, okay. We have to go up to 117,000. I misread that. 117,000. So let's not do that. I think is that doable? Yeah, that's not going to take too long. A few seconds. Less than a minute, surely. If it works, I might still have an incorrect program. Maybe 15 seconds here, 30 seconds, I don't know. We overshot, didn't we? 117,000? Yeah, I missed it. 117, let me just copy and paste that. This output is way too long. Am I resetting these things correctly? I need another drink, so I will be back in a second. Part 2 doesn't sound that much harder. Like, brute forcing the test input isn't that slow. But why can't I get the right answer? A register is initialized to 117,440. This is ignored. Positive. Oh, yeah, they do explicitly say it has to be positive. Okay, what if I don't iterate, but I just do part 1 and see what that outputs? Because like it should be the same as what I'm doing for part 2. And then if I hard code my test input, 117440, I think that's it. Yeah, that is not the right output. Are there other operations that I could have messed up? Let's bring back this and see if I covered every instruction. One 167430. What? Oh, that's not the right input. 463563. 4635635210. Okay, so that's correct. Yeah, and then which instructions am I covering? That's not the log that I wanted to edit. That's the log. Okay, so instruction 0, we covered. 1, we don't. Well, yeah, so I want to run the real input, at least, for part 1. That covers instruction 1. And is this still the right answer? 167430. 506. Yeah, that's right. So we cover instruction 1 and 0, 2, 3, 4, 5, 6. We never do 6. Did the test input cover 6? Anyway, what is 6? BDV. If I got ADV and CDV right, I better have gotten BDV correct. The only difference, A is still the numerator. The only difference is the result is B. Then what about the jumps? Still a lot of 0 jumps, but no non-zero jumps. This is the test input. This is not the test input. Only ever jumps to 0. That's weird. And I'm getting the wrong answer. Okay, which instruction is out? It's not like a substring of the output, is it? Oh, 3, 5, 4, 3, 0. So I have those numbers in my output in that order, but I just have a bunch of other numbers. So 0, 3, 5, 4, 3, 0. And then I'm just outputting a bunch of other stuff. So how could that happen? What is going on? Okay, we have register A. Now this one should not, this is just part 1. I should be able to run part 1 with the test input and just set this. Is this a different example? Oh my god, this is probably a different example. Oh my god, it's a different, I pasted the wrong thing, but 035, this is a different program. What the fuck, man? I just assumed it was the same example from part 1. What the fuck is that? That again, that's a skill issue. I just didn't read the input carefully. Okay, so what does that do? Still wrong, because I have to change this to that. Okay, so that works. And then can I do part 2? Again, I should just be able to brute force this. So am I calling this? Let's call it. I don't know what I did. I probably added a bunch of debug output. Not really. But I still have like a hard-coded break. So it should be correct. So like I actually ran 2 more. 0 through 5, 4 through O. Actually outputs the same thing in the next 2 iterations, so that's interesting. Anyway, we had, yeah, you don't want to do this. You just want to naturally break at this point, not by hard coding the known answer from the example, or +2. Because I thought I might have an off by 1 error, so I checked 2 more. Or maybe an off by 2 error. What happened? That's not good. What happened? Program. Did I get the program string correctly? Oh, no, because I have to chop off. This is actually the whole line. So program string is this, including program colon space. So I don't want to compare with that. I want to chop off that part and then just get the numbers. I think it's easiest to start from the numbers that I've parsed and then reconcatenate those onto another string. You could like split the string at the semicolon and then also chop off the space, but that feels like, excuse me, that feels like more work. So that's wrong. Let program string equals empty string. And then for P in program, program string plus equals string P. Can I do that correctly? I need commas. And then I have to chop off the comma too. I should have done it the other way. How did I trim? Let's trim like that. Except out string is program string. Okay, that was too much work. So can I just iterate through all that stuff now? Again, I feel like this is taking me longer than it should. There we go. Now, can I do that on the real input? How long is it going to take? Let's give that a couple minutes at least. Hopefully it's not like too big. Hopefully this doesn't require anything more than brute force. Program really that long? 24137 Okay. How many characters is this? 31? Yeah, 31 characters. 31. Okay. 63 million? I mean, I don't know if that's anywhere near the right answer, but if I have to get into the millions, that's going to take a while. So maybe I should do this optimization where you check if your program is longer than the expected string. and then you can break. This is chugging away. Maybe I shouldn't T the log. So we're over 1 million. Haven't found an answer yet. Oh yeah, you can do more optimization, so you can compare the first value. So maybe I do want the program as integers. And then if you ever get a different number than the expected number, you can break earlier. You don't have to evaluate the whole thing. I think that's worth doing. So we're actually not going to use program string at all. And then instead of else string, we don't need the whole vector. We just have to compare the current number. So that's the number of numbers that we've output so far. Am I editing part 2? Okay, I'm editing part 2. And then let's not log so much. Actually, my computer is making all kinds of noise, so I'm just going to kill that. So if modulo 10,000, let's try that. I don't know if that's too much or too little, but we'll see. So n out, and then instead of out string, actually don't need to build the string. So we don't have to output anything. And then let out val equals operand val modulo 8. That's the number that we would output if we were building a string. This is an integer, and then we're just going to compare this integer to the program integer vector. And we don't have to do anything with the string. I don't think we have to do anything down here. And then instead of breaking in here, we can just compare one number. So if outval not equal program and out, what do I want to do? So if that happens, I want to go here. So I want to break out of this loop, but try the next thing, because this is the wrong answer. Wrong answer, and you don't need to evaluate the rest of the program. So we can break. It's different from, see, this break is outside of this while loop. This brace closes the inner while loop, which evaluates the program, and it iterates over instruction pointers. So we're breaking out of the program evaluation here. And then else, so they are equal, and if we're at the end of the string, actually, I have to check bounds first because this might overflow. So that's gonna take care of one of my other conditions at least. So if n out is greater than, do I just have to do size program? Do I already have this in a variable, or do I just have to call size? Let's make that a variable. It might help performance. Greater than, I think greater than or equal, right? Because it's exclusive of the upper bound. Answer too long compared to expected output. Then we can also break. And otherwise, I don't think we have an else. But then I still have to know if I get the right answer. So these are wrong answers, and then we break out of the inner loop. True. False, that's the wrong answer. A quine is a program that outputs itself, in case you didn't know. And then if is quine and n out equals n program. Do I increment n out? I have to increment this somewhere. Equals. Will that work for the test input? I should be able to find out in hopefully less than 15 seconds now. It might be faster. 97 equals 0. That's not right. Should stop at 117,000. So this is quine. Something is wrong here. So if it's too long, it's not a quine. If the output value doesn't match, it's wrong. Okay, I've got to do this again. I don't have a string now, so that's problematic. Six. So why is it false? Initialize to true. If it's too long, by resetting this at each iteration. No, I set this in the wrong place. That'll do it. Okay, and then it didn't print that stuff. That means it hit the other break. So I think we don't need the hard-coded break. That's not what I wanted. So it should just hit this break naturally, and that means it found the right answer by itself without any hard-coded expected value. Okay, that was a lot faster. It took 15 seconds when I was comparing the entire output, and now that I'm aborting early, as soon as I know that the answer is wrong, that's more than 15 times faster. So I think the this modulo, let's bump it up to 100,000. And let's run the real input again. So it still might not be optimal enough, but from the benchmark of the test input, it's at least 10 times faster, at least 15 times faster, maybe more like 16. It's already at 1 million. I think I let it run for like a few minutes before it got to 1 million the first time. So that's good. But if I have to go up to 63 million or more, I have no idea if this has any relation to the part 2 answer, but this is an order of magnitude that could happen. That could take a while. Is this like 3 million now? So like 1/20th of the way to this. All right, I need some chapstick. I'll be back in a second. Is that 10 million? Yep, about to hit 12 million. So maybe like 1/5 of the way to this number. Again, I have no idea if that's anywhere near the answer for part 2. But I'm kind of expecting that this is a similar order of magnitude as the answer. How would you optimize this? How long has this been running? Time 3 minutes? Is this time like wall time? I don't really know. That seems about right, but I have no idea how good my intuition is. So we're coming up on 4 minutes. And it's at 17.7 million. So 4 minutes is like 17.7 million. And expected answer maybe what? Do I have caps lock on? What the hell did I do? I don't know what I did there. 6, 3. So let's do some math to estimate how long it'll take to get there. So this divided by 17.7 million times 4 should take about 12 minutes. So how much longer is that? We're at 5.5 minutes. So another 6.5 minutes, and maybe we'll be close to the answer. That's not terrible. But I think I'm going to set a timeout here. If we get to, it could be like plus 10% or something. I have no idea if this number is anywhere near the actual answer. But if we get up to like 70 million, and that should only take, we should be there in less than 10 minutes. If I get up to 70 million and haven't found the answer, I think I'm going to give up here. Halfway to 60 million. We're at 30 million. Seven minutes. Maybe it's a little slow. It takes twice as long as, if we're halfway there, maybe it'll take 14 minutes, not 12. Oh, this was integer division? Yeah, 12.0 should have been, okay, 14 minutes. That is correct. How did that, oh, because it rounds this first and then it multiplies by 4. Okay. I should have noticed that 12 was suspiciously round. Yeah, so time estimate is a little bit longer than I initially thought it would be. But like another 10 minutes from now, we'll probably be at, okay, that's halfway to 70 million. It's more than halfway there, and we're 8 minutes. So another 8 minutes, we'll be at 70 million, theoretically. Because of the way this breaks early, like it might be faster for some programs and slower for other, not programs, but register A initial values. So this might not be uniform progress, but I think from what it's logging, it seems to be roughly uniform. I mean, it evens out. If I only print one every 100,000, then some individual programs might be slower or faster. But if you group 100,000 programs together, it takes about the same amount of time as the next 100,000 programs. How would you optimize this, though? Like, do you have to like predict the output before you evaluate it? There's got to be some kind of dynamic programming thing or some magical algorithm you could use. Who else is streaming? In 10 minutes. Okay, Bad Cop is live.
Yeah, this is a better example.
The garden plots. It's been going for an hour.
So the way I'm doing it right now is I'm saying like, okay, this one has a perimeter of 3.
All right, I'm just gonna stream
because
snipe
it is exposed on 3 sides.
because this is gonna take like another
But
5 minutes at least to run.
really, it's got a perimeter of 2.5.
Day 12.
So you have to dedupe.
Oh yeah. One of my viewers had to help me a little bit with day 12 part 2. I think it was Vision for All. So yeah, they told me to count corners, not sides. Sorry, spoiler for day 12. But if you're watching me solve day 17, I think spoilers for day 12 are, not out of the question. So if I hadn't gotten that tip, I think part 2 would have taken me a lot longer.
Or do we do it in post? Do we find them all after the fact? What would that look like? I'm doing it in fence post. Yeah, it's almost like you wanna trace the shape and count how many times you turn. That would be good. But how would you even do that? Or you could put all the edges into a set of some kind. I was trying to think of like what
This is called stream sniping.
Like if it's a vertical edge.
No. Not this definition, at least.
And it's along some column, but that's weird because like you could have shapes that doesn't work.
Just keeping an eye on the progress here, but I don't have much else to do while it runs. I have no idea how to optimize this, so if it runs for 5 more minutes and doesn't get the answer, I'm fucked.
This is a tricky one. I'll give you that.
I can fish.
Is there some search order that makes this nice? No, because we're doing flood fill. So it can
M3SK.
kind of happen however it wants.
Let's fish. Seahorse. Where's my seahorse? I don't like my chances here. Oh, he only has 1 win. Huh? He might be in the game here. Go, little seahorse. Go, little seahorse. Yeah, I got it. Oh, yeah. I came out on top.
So how many edges does C have? It has 8. Hmm.
Eight? How? This is part... Oh, this is part 2. Oh, yeah.
I wonder if looking at it from this diagram is going to help me.
We're almost at my cutoff point. And I'm going to let it keep running off stream, but I'm not going to sit here and watch it while live streaming.
could push all the edges and then try to like merge them.
This fish is doing all right. All right. Yeah, this is not finishing in a reasonable time.
So
Thought
how do
maybe
you know the
63
time range?
million. Let me mute
It's
that.
like,
I thought 63 million might be around the order of magnitude. There it is, 70 million. I thought that might be around the order of magnitude of the answer for part 2. And we're more than 10% past that now. So I'm not going to sit here all night streaming and watching this. I'm going to let it run, and maybe it will get the correct answer overnight, but I'm not going to live stream that. So, yeah, I think I might raid Bad Cup. Should I commit? I'll commit after the stream. You'll see it on GitHub. Check out my links. All right, let's raid. Yeah. Thanks to everybody who tuned in. I really appreciate it. I will catch you next time. Bye.
hey, thank you for the raid. How was your stream? Part 1 was okay. Part 2's running. Classic.